Hello, my name is Kaan Beyduz, and I'm an undergraduate mechanical engineering student. My poster is about sinking velocities of microplastic particles under still water. Microplastics in oceans can aggregate near coastlines due to surface waves and underwater currents, moving them back to the shore. In long term, nutrition resources for marine animals can get contaminated due to microplastics, and if ingested in high quantity, they can accumulate in the marine animals' digestive systems. Although marine animals are directly affected by this, the food chain and most human food resources are at risk indirectly. In this study, we investigated 5 different densities and 17 in total different particles in order to observe the effect of diameter, the characteristic length, and also the thickness of the particle, specifically for ellipsoid. For the experimental setup, a 32-inch long water tank was used, and a camera was implemented in order to capture the image of the particle when the particle was released and enters to the field of view. A dropping mechanism was implemented in order to release the particle consistently in each experiment, and a special care was given in order to not have external disturbances from the dropping mechanism, and the particle can settle before it enters to the field of view. A control board was implemented in order to synchronize the release of the particle with the image collection of the camera. So when the particle enters the field of view, the camera would start capturing the image of the particle, and we would have consistent experiments along each trial. Later, image processing tools were used to determine the centroid of the particle in each frame of the total time series. The centroid data was later used for determining the settling velocity of the particle. The results show that spherical particles and ellipsoid particles had the lowest deviation in their x and y velocity components. The highest deviation was in the rods, and specifically for cyan rod. Spherical particles had the highest settling velocity compared to ellipsoid and rod geometries. Among spherical particles, Thorlon sphere had the highest overall settling velocity among different dimensions. Because rod and ellipsoid particles are non-symmetrical, their characteristic length was used to compare it with the settling velocity. The highest deviation in the settling velocity was observed in cyan rod CRL, and the highest settling velocity was observed at cyan ellipse CEF. The lowest settling velocity was observed at black rod BRS. Looking at the densities, the highest density, cyan ellipse, also has the highest settling velocity, while the lowest density one, black ellipse, has the lowest settling velocity, although their characteristic lengths are similar. The cyan cylindrical rod case was further investigated as its settling velocity demonstrated oscillation. The x and y components of the velocity demonstrated a pattern on the orientation of the particle when it was settling. Each frame was analyzed, and through the time series that we have for x and y components, we observed that at specific points and at the maximum and minimum points of the x and y velocity graphs, the particle demonstrated similar cases in multiple trials. In conclusion, further analysis is required for the cyan cylindrical rod case, specifically the kinematics behind this oscillating settling velocity. For spherical particles, as the diameter increased, the settling velocity also increased. For density, the highest density particle had also the highest settling velocity. For non-symmetrical particles, the characteristic length didn't have a significant effect on the settling velocity, while the density had a significant effect on the settling velocity, as can be seen from cyan ellipse. Thank you.